Hey team, it's Mr. Z, and today we're going to look at crafting quadratic functions with specific key traits. So the idea is that you're going to have to really know the vocabulary, and you're going to have to translate each part of the question, because we're going to give you just enough information to create a function, and you're going to need every single piece. Let's go ahead and dive on deep. So basically the idea with these is we're going to have to look at these and see what kind of form we're going to write. Remember, our options are standard form, vertex form, and factored form. So let's go ahead and look at number 7 and see, hey, which one is it going to be? It's a quadratic function that is concave up. Concave up. It is going to be compressed vertically, and it has zeros of 6, 0, and negative 2, comma 0. Okay, so looking at it, the key part is that the zeros of 6, 0 and negative 2, 0. Looking at my previous work samples, I mentioned that the zeros are the x-intercepts. The x-intercepts, aka if I were to graph these points on number 7, 6, 0 would be over here, negative 2, 0 would be over here. These zeros are called x-intercept. Okay, that being said, x-intercept zeros, this is automatically going to have me use factored form. So let's go ahead and look and see what it's like. Factored form. A times x minus r1 times x minus r2. I am going to write it. The reason I'm going to write it is because the writing is the key to your memory. This is the generic form for every single quadratic in existence. Notice factored form. Big deal. Why we spend so much time on it. Go back, practice, get better. Go back to boot camp if you need to. So now I go ahead and check. And this is just an important thing is notice how I put a plus R2? That's bad form. I got to just take a moment and reflect. Did I write down the formula that I'm referencing correctly? Okay, let's go ahead and look at some key information. Concave up. Okay, I was remembering that that's always the leading term. This is going to be my A term. That's what I'm going to look at. So when I'm creating a new equation, I want A to be concave up. I know concave up is going to look like this. So that means A is going to be positive. So I'm going to go ahead and put a positive sign. Then I could pick a number. I'm going to pick any number. However, this next part tells me compressed vertically, and there's basically two quick cases. It's either going to be compressed or it's going to be expanded. And when it's compressed, you have to remember that it's going to be a fraction. For example, I'm going to compress this into half the size. Again, I'm going to repeat. Since I am compressing it, it is going to a fraction that is less than 1. I am going to compress this parabola, and what I'm going to do to it is shrink it into half the size. Next up, I'm going to go ahead and rewrite my parts. These are always the same, x minus blank and x minus blank. Notice how I did that. I'm going to now generate the information. It is going to be 6. Notice how I'm only using the x part, aka when it's x equals 6, x equals negative 2. They are referencing the x part of a coordinate. Now I'm going to write negative 2. Now, technically, this is the equivalent answer I'm looking for. However, mathematicians have a habit of simplifying work in order to get an equivalent expression that is as clean as possible. So the only thing I need to change in this is I can omit the plus sign. I can write it as 1/2 times x minus 6, and it's going to become x plus 2. Taking a moment to further look at this, go back in time. What are the zeros of this function that I'm looking at? If I'm just looking at the final answer, notice how I can see, okay, it's a minus sign. X minus 6, the 0 is 6. Since it's x plus 2, I visualize in my mind's eye that it's x minus a negative 2. So I can see, just looking at this quadratic function that is in factored form, I can see the x-intercepts visually without doing much work. Remember, it's about going both ways. Looking at an equation and telling me all about it. And if I give you the traits, it's like, go find me an equation that looks like this. Okay, this next one. Writing a quadratic function that is concave down, has a vertical stretch, and has a maximum. I know concavity has to do with my leading term. I know a vertical stretch is going to deal with that a term, but it's going to be a number and it's going to dictate what I choose. And then this has a maximum at -1, 5, or -1, -5. Okay. Well, all my forms can determine concavity. So I have to really look at this word maximum. Well, maximum is a vertex. Vertex form tells you the vertex coordinates, and then this transfers to maximum or minimum, depending on if A is positive or if A is negative. The reason being, if A is positive, got that backwards. Notice how I was able to determine that. And this is a key part when you're doing your math. A is concave up. Notice the bottom part of this. The point at the very bottom would be considered the minimum. Here, the point at the top would be max. Okay, so jumping back to this, I need to write it in vertex form. The reason being is that it is a maximum is given. So I'm going to go ahead and look at my reference guide until I get this by heart. I'm looking at vertex form, and it is g of x. Why did I not write f of x? Even though the vertex form I'm referencing says f of x, I see this guy is saying, hey, name this function that you're writing for me as g of x. Now I'm going to go ahead and continue, and it's going to be a times x minus h squared plus k. Okay, continuing, let's go ahead and generate this out. G of x is going to be concave down, which means that it's going to be a negative number. What number is it going to be? A vertical stretch is not a compression. When you stretch something out, you're making it bigger than it originally was. When you are stretching it, you're going to have to multiply by a number that is bigger than 1. So I'm going to say 2. So I'm going to stretch it twice as big. It is going to be concave down. And then now I'm going to go ahead and just simply plug in my vertex. Which coordinate goes where? Well, for a maximum and a minimum, it is always going to be the HK. It is always going to be the HK. So the X part of the intercept is going to be the H, and the Y part is going to be the K. Looking at it, I see that -1 is going to go in the inside for H, and I see for K, it is going to be a -5. As all good mathematicians do, when I'm creating an equation to turn into my boss that was specifically requested, I'm going to clean it up and rewrite it as g of x is going to be equal to negative 2. I'm going to rewrite the inside as x plus 1 squared minus 5. Looking at this final form, remember you're able to go both ways. I can see that it is concave down. I gave it the right name of g of x. The stretch is coming from me stretching this twice as big. The final part is, even though it says x plus 1, I have to train my brain to think of it as x minus a negative 1. Because at sight, I can visualize this maximum is going to be at negative 1, negative 5. All right, that one was a big one. Welcome to the world of quadratics. We're doing second degree math.